Hello viewers, in today's class we are going to discuss one important and definite integral involving absolute value function, right? So here we have to calculate the value of this definite integral, in which we have the absolute value function 2x square plus x minus 1 and from minus 2 to 1, right? So let us start. So let us first call this integral as I, right? Now see, here we have a quadratic function inside the absolute value function sign, right? So let us first solve this quadratic equation, that is 2x square plus x minus 1 equal to 0, in order to get the critical points, right? So this is a quadratic function, and by splitting the middle term, we can write 2x square plus 2x minus x minus 1 is equal to 0, and we can write 2x x plus 1 then minus 1 x plus 1 equal to 0. So we have 2x minus 1 and x plus 1 equal to 0. So we have 2x minus 1 equal to 0, x plus 1 equal to 0. So x is equal to half and x is equal to minus 1, right? So here the two critical points are minus 1 and half, right? So now we can represent these 2 points on the number line. So here we have the number line, here we have minus infinity, here we have infinity, and let us have these points here. We have minus 1 here, and then here we can write 1 over 2, right? So now let us make use of the definition of absolute value function. So we know that if we have mod of y, then mod of y is equal to plus y whenever y is greater than or equal to 0, and minus y whenever y is less than 0, right? So now here y can be replaced by 2x square plus x minus 1. So 2x square plus x minus 1, the absolute value of this quadratic expression can be written as here we have plus 2x square plus x minus 1 whenever this expression 2x square plus x minus 1 is greater than or equal to 0, right? And similarly here we have minus 2x square plus x minus 1 whenever 2x square plus x minus 1 is less than 0, right? So now this can also be written as plus, here we have 2x minus 1, because the two linear factors of this expression are 2x minus 1, x plus 1, and here we can write 2x minus 1, x plus 1 is greater than or equal to 0, and here we have minus 2x minus 1, x plus 1, and 2x minus 1 and x plus 1 less than 0, right? Okay, so now see, here we have these 2 points by solving this equation, and here we have half and here we have minus 1. Now we see that this real number line is divided into 3 distinct intervals by these 2 points. So the first one is the interval minus infinity to minus 1, the second one is minus 1 to half, the third one is half to infinity, right? Now we have to assign a sign to these intervals, and see whenever x lies between this interval, right, that is half to infinity, then let us see the sign of this expression, that is 2x square plus x minus 1. So this is 2x minus 1 and x plus 1, right? So whenever x lies between half and infinity, then let us see the sign of this expression, right? So for example, let us take some value here. See, here we have to integrate this expression from -2 to 1. So obviously 1 would lie between half and infinity. So let us take 1 here, right? So if we put 1 here, then we see that this is 2 times 1 minus 1. This is 1 plus 1. So this is 2 minus 1 is 1 times 2, that is plus 2, right? So when x lies between half and infinity, then the sign of this expression is positive, right? So here we can write plus. Now let us come to the second interval, that is -1 to half, right? So then the sign of 2x square plus x minus 1 is, see, this expression is equal to this one, and in the interval -1 and half, see, here we can take a value, say 0, because 0 lies between -1 and half. So if we take 0, then here we have 2 times 0 minus 1, here we have 0 plus 1, so this is 0 minus 1, this is 1, and here we have -1 times 1, that is -1, right? So see, here we have negative sign. So it means whenever x lies between -1 and half, the sign of this expression is negative, right? So here we can write the negative sign, right? Now let us take the third interval. See, here we have minus infinity to -1, and then the sign of this expression can be obtained by taking any value between -infinity to -1. So let us take -2, because here -2 lies between -infinity and -1. So if we substitute -2 here, then we have this expression, and this is -4 -1. Here we have -1, and this is -5 times -1, and this is minus multiplied by negative, two negative signs multiplied gives us the positive sign, right? So here we have plus, right? So the sign of this quadratic expression is positive here, right? So what we have discussed so far, that inside the absolute value function sign we have the quadratic function, and when we solve this quadratic equation we get 2 points, and these 2 points divides this real number line into 3 distinct intervals, and we have assigned the sign of this quadratic expression in these 3 intervals by taking some value lying between these 3 intervals, right? So this is how we assign the sign of this expression, right? So here one interesting thing, we note that here we have plus sign, then we have minus, and then we have plus. So this is alternatively plus minus plus, right? Okay, so now once we have done this stuff, we can now split this integral into the sum of 3 integrals. So now viewers, here this original integral can be written as a sum of three integrals, and the first integral I1, see here we have to integrate it from x equal to -2 to x equal to 1, so we have to go from -2 to 1, right? So now I1 can be written as from -2 to -1, right? Because here from -2 to -1 we have the positive sign, right? So we can write from -2 to -1, and here we have mod of 2x square plus x minus 1 dx, and the second integral I2 is from -1 to half, from -1 to half, and here we have mod of 2x square plus x minus 1 dx, and the third integral is from half to 1, right? From half to 1, and here we have mod of 2x square plus x minus 1 dx, right? Okay, so now see here this can also be written as -2 to -1, and the sign of this expression is positive here, so here we have plus 2x square plus x minus 1, right? And here we have -1 to half, and when x lies between -1 and half, we have here the negative sign, right? So we have -2x square plus x minus 1 dx, and then we have half to 1, and 2x square plus x minus 1, the mod of here we have the positive sign, that is from half to 1, so here we have the positive sign. So this is 2x square plus x minus 1 dx, right? Okay, so now we have three integrals, and we can solve these three integrals one by one, and then we can add up the values of these three integrals. So now viewers, I1 can be written as the integral of x square is x cube over 3, so we have 2x cube over 3 plus x square over 2 minus x, right? So the integral of x square is x cube over 3, and integral of x is x square over 2, and integral of 1 dx is x. So here we have the limits -2 to -1, right? Now substituting the limits, we have, so I am writing it directly, so we have here -2 over 3, then we have plus 1 over 2 plus 1 minus we have here -2, so this is -8, and -8 times 2 is -16 over 3, then we have plus 4 by 2 plus 2, right? And if we solve this expression, then we'll get 13 over 6, right? So now I2 is from -1 to half, minus 2x square minus x, and minus is plus, so here we have plus 1, right? So now this is minus 2x cube over 3, then we have minus x square over 2 and plus x, and the limits are from -1 to half, right? Okay, now if we substitute the limits and we'll take the difference, then we'll get -1 over 12, then we have -1 over 8, and then we have 1 over 2, right? Then minus, if we take -1 here, then we see that this is 2 over 3 minus half and minus 1, right? So I am not going to simplify it, and I am writing directly the result. So if we simplify it, then we'll get 9 over 8, right? Now similarly, I3 can be written as half to 1 2x square plus x minus 1 dx, and we can write this expression, right? So 2x cube over 3 plus x square over 2 minus x, and the limits are from half to 1. Now if we substitute the limits and if we take the difference, then we'll get 2 over 3 plus 1 over 2 minus 1, and minus we have 1 over 12, and then plus 1 over 8, and minus half, right? So again, I am not going to show the simplification of this expression, and we are directly writing the results. So here we have 11 over 24, right? So the value of I1 is 13 over 6, and the value of I2 is 9 over 8, and the value of I3 is 11 over 24, right? And if we take the LCM and we take the sum of these three fractions, and then we simply get 15 over 4, right? So the given integral is equal to 15 over 4.